Yeah, so welcome back, guys. This is Madhav PVL, and today we're going to see DA CO3 and CO4. And for DA CO3 and CO4, I didn't prepare any notes. I'm directly I'm just directly learning that only from our college PPTs and also from some YouTube videos. So now I'm going to explain you completely with the help of our college PPTs, KLU University PPTs. So now let us get started with the first one, that is dynamic programming. So now what is dynamic programming? So in this PPT, this whole PPT is regarding the concept of dynamic programming. So dynamic programming is just for solving the optimization problems and getting many solutions. These all things I think you can read it very easily in this PPT, and these are not important, but the important are these two slides, that is differences. So what is the difference in between the divide and conquer and dynamic programming? So divide and conquer is partitioning of a problem, whereas this is partitioning of problems by overlapping subproblems. So it doesn't store solutions of subproblems, it stores the solutions of the subproblems to avoid calculations. So this also you can just see this is from top to down approach, and this is from bottom to up approach. And then this is also one of the differences question, that is what is the difference between the dynamic programming and greedy method. So dynamic programming is for optimal solution, greedy method is also for optimal solution, but dynamic programming will just think about the future and it chooses the step, whereas greedy method will take the choice at that particular instant, and it is guaranteed that dynamic programming will generate an optimal solution, whereas in greedy method we cannot give any assurance of the optimal solution. Further the example is 01 knapsack, further that is a fractional knapsack. So this is all about the first PPT. And then optimal binary search tree, even I am not aware of that completely, so that's why I will try to make another video, else you can watch the videos in YouTube. I am not completely aware of this optimal binary search tree. And then knapsack, major every one of you know what is meant by knapsack, because the people who took MP1 advanced is aware of this knapsack problem. So there will be a basket and there are some items along with their profits, so person need to just put them in the basket accordingly. So for that reason we need to follow this method. So now I will solve this in the paint. I will solve this now. So this is a problem. So now basically this is nothing but we need to start from the initial weight of the bag. So initial weight of the bag is 0, 0. So if it is 0, 0, then by adding one of the element and one of the profit, here the first is weight comma profit. So now we will add the first weight, that is 2 comma profit, that is 1. So how to do that? We can do that like this: 0 plus 2 comma 0 plus 1. So by doing that we are going to write the both. After adding this we will add the both like this: 2 comma 1. So why it is like this, I will tell you at the ending of this problem by watching the PPT. So now again we will add the next one, that is the weight is 3 and then the profit is 2. So I will also add that to these both. So 0 plus weight is 3 comma 0 plus profit is 2. So again I will do this for the remaining also, like 2 plus 3, 2 plus 3 comma 1 plus 2. So in this way I am going to add for these both also. So now again with the above ones we are going to add it again. So 0 comma 0, 2 comma 1, 3 comma 2, that is 0 plus 3 plus comma 0 plus 2, and then 5 comma 3. So in this way we are going to add now. So until here it is fine, and also we are remaining with the last one, that is 1 second guys. So we are remaining with the last one, that is weight is 4 and then profit is 5. So now we are going to add even that. Weight is 4, profit is 5. So we are remaining with the last one. I think some problem is there, that's why everything is gone. So now we will do the last one, that is 0 comma 0, 2 comma 1, 3 comma 2, and then 5 comma 3, and then at last 4 comma 5. For that we need to add for this 4 things, that is 4 comma 5 comma 4 after 5 6, 6 comma 6, and then 4 after 5 6 7, 7 comma 7. Yeah, I think for this 4 we had done only 3, and the last one we need to add for 5 comma 3, that is 5 plus 4 9, 9 comma 5 comma 3, 5, 9 comma 8. So in this way we are going to do this problem, but we need to use this flower brackets. So with the help of this flower brackets we are going to find out the last solution until here, which we had found there, and we also need to write this initially as S0, and then this is S10, and this is S1, and this is S11, and this is S2, and this is S2 S12. So in this way you are going to represent it for the representation purpose, and also by applying a purging rule, 3 comma 5, 7 comma 7, 8 comma 9 will be discarded. This is because the weight should be m of 6, but here it is exceeded. 3 comma 5, I think the weight of 3 nothing is there, I think so. Yeah, fine, weight of 3 it is there, but we need to consider the value of 6. I don't know why it is removed, but these two had exceeded the weight. So now we need to do for the remaining values, like I will just show you in this example. So after finding all these things, basically we require the minimum weight value as 8. So in this the weight value is 8 is only here. Here the weight is 8 and also the profit is 8. So we will consider this pair and we will just subtract it with the previous one. So 8 comma 8 will be subtracted with the previous one, and again we will get the S3. So now where is this 8 comma 8? 8 comma is situated in S4, whereas 2 comma 3 situated in S2. So hence x2 is 1 and S4 is also 1. So x4 is 1, x2 is 1. So finally our solution is 0 comma 1 comma 0 comma 1. I think this made some sense. So we need to find out the final solution, and after finding out the final solution we need to see what is the minimum m value. So after getting the minimum m value we need to subtract that order pair with its previous one, and we need to keep ones for those both, and that is basically a knapsack problem. So as this is a final exam, it is better if we know some good knowledge about this concept of knapsack, and also the algorithm if possible. Try to write it on your own. The algorithm can be written on your own. So now this is about knapsack problem, and then now let us get into the next one, that is travel salesman problem. I think travel salesman problem is also I think it is known by everyone. So you need to visit all the cities with a list, and you need to finally visit to his home place, and he should visit everything only just once. So we need to find what is the shortest route with the help of this travel salesman problem. So these are all things you guys need to remember, and then here we can just see now. So in this way they will just give some question. So let us try to copy it and paste in the paint for our purpose. So now here we can just name it like this. Yeah, A comma B comma C comma D. So the above one also the same. I'll write it down here, a comma b comma c comma d. So in this way we are going to write. So now we can just make some order pairs from this. So we can just do like, if he touches a, then he can touch c d b c d, he can touch this 4. So if it is touching b, so he can touch a c d. So if he is touching c now, so he can touch a b d. So if he is touching b now directly, so he can touch a b c. So in this way we need to write the order pair for this problem. So now we had written from the base level. So for writing that in a base level, we need to make sure draw a calculation graph like this. So what is this calculation graph? Calculation graph is nothing but representing this whole order pair like a graph. So if he touches a here, then he need to touch b, c, d. So after touching b, from b he need to touch b or c, d. So from c he need to touch a, d. From d he need to touch a, b. So in this way we need to just write out like this, and we need to make a solution form. If he touches c, he will touch d. So after making this, you need to just draw it from the base level. So from base level, if you just go up, you will get the values of that particular minimum cost of reaching the goal node. So in this way also you can work, or else you can just work by writing the whole order pairs from the starting itself. You can work in either ways, both are easy. So in this, what is the benefit in this graph model is just nothing but you will initially know what is the least cost for traveling for the A, because you will calculate them very easily, and you can just draw out the order pairs very easily according to that particular graph. So you will come to know what is the solution from this graph initially without any struggle. So that's the reason you can choose any of the ways. And but the thing is, I think you guys must have understood this. So with the use of this matrix and graph, you need to find out the minimum cost for the traveling. So next one we will see Fort Fulkerson. So this is also one of the important question which we can expect in the examination. So now here we can just see. So basically you will be given a question like this. So this is a network. So you will be given a question like this, and this is S and this is T. You need to reach S to T with a minimum cost. But with the help of this Fort Fulkerson method, you are going to know what is the minimal path in which you can just reach that particular position. So for that, basically now initially I am considering from S to 3, 3 to 4 and 4 to T. So now we need to take what is the minimum most value from this 3. So from this the minimum most is 2. So we need to subtract 2 from the minimum most is 1. So you need to subtract 1 from this both. So here 1 will be remaining, and here it is 0, and here we will remain with 2. So that is all we are going to write now. So for return it is taking 1, and here also this side we are getting it as 1, and for here also the 1 is removed and we will get back 1. So in this way the first way is created, and now second we are considering like from S to 4, 4 to 3, 3 to 2. So as we had discussed, now we can just get back 1 from here, right? So we are using that particular thing. So now 2, 1, 2, in this the minimum value is 1. So here we will get a reverse of 1 here, and here we will get a forward of 1 here, and we will get 1 of reverse. So in this way again we are going to write it now. So forward backward we are getting 1, and here also forward we are getting 1, and here the backward also 1. So in this way we got all those things. And then now again we will go from the upper path, because here we got 1 forward, 1 backward, so this path cannot be used. So here also we got 1 forward and 1 backward, this path cannot be used. So these two paths cannot be used, that's why we are coming from the upside. So the main thing is, even after reducing the values, there shouldn't be anything like 1 or 1. So forward 1, backward 1, if you are getting like that, you cannot use that particular way. So now we will go like in this way, and we will get the 1 now. So he will try from the above level. So after trying it from the above, okay fine, so even the below level is still remaining. So it's traveling from S to 3, 3 to 2. So now we will reduce one value here. We will reduce the one value here, and we will increase the reverse value as 2, and we will reduce the one value here, and this path is cannot completely not use it. So now we will travel from the upper path. So S22, 225, 5 to T, here the smallest value is 1. So we will get a 1 reverse from here. Okay, we are reducing from 3 to 2. We are getting 1 from reverse, and then 3 we are getting, and 1 for reverse, and then here 1 for reverse, and forward it is 0. So now we need to note down all these green values in the next graph for the representation purpose. We had covered all the nodes, and this is a green graph with which you can travel. And if we need to find the minimum most to reach that particular place, it is 2 plus 2, it is 4, otherwise 1 plus 2 plus 2. So this is 1 plus 2 plus 2 you can use, it is 5. So this is an optimal flow for using this thoughtful Gaussian method. Think this made some sense. So this is a theory which you need to just read it. So this is the algorithm for it. So for GEST, for HE, we need to just check for its residual graph if there is just an augmenting path. So augmenting path is nothing but if there is anything to subtract. So if there is anything to subtract, then we consider it as an augment path, and we will update the reverse value. G of f is the reverse value, and we will return the f. So this is an algorithm you guys need to remember. But this is the process for implementing this thoughtful Gaussian max flow. Think this made some sense. Now let's get into the next one. Bfs and Dfs. So as I had said before, breadth first search and depth first search is nothing but implementing them with the help of queue and another one with stack. I think I explained it in a paint also, but here we will see with the help of this PPT. So now initially I am considering the V value and I am putting it in a queue. So after cancelling the V, what are the corresponding elements, that is V1 and V2, we will put them in this particular queue also. So after cancelling this, I think the whole process is, here the whole process is done. So initially, so we will try to paste this in paint and we will work on depth first search and breadth first search. So now here we can just see, like if we are considering a queue, so if we are considering the queue, so first initially we will visit 0. So after visiting 0, we need to cancel the 0 and we need to place them in visited list. We had added 0. So after adding 0, what are the corresponding elements of 0? They are 1, 2 and 3. So after watching this 1, 2 and 3, you need to just cancel the 1 now. So after cancelling 1, you will be remaining with 2 and 3. So 1 is visited. So with 2, if you cancel 2, you will get 3 and 4. So 2 is also visited. So after visiting 2, you are remaining with 3 also visited. For 3 it is not having anything, so 3 also gets visited. So remaining with 4 will also get visited. So this is breadth first search, and then depth first search is with the help of a stack. So with the help of a stack we will do now. So we will write in a reverse order, so that is 0. So after cancelling 0, we will be remaining with 1, 2, 3. 3 comma 2 comma 1. We need to write in a reverse order. So now after cancelling 3, we will be remaining with 1, 2 and 1. So after cancelling 2, we will be having 1. So 4 and 1. So after cancelling 4, we will be remaining with 1. So in this way we are going to check it out with the help of a stack, the depth first search. So this is a concept you need to just remember, and this is a very simple algorithm. You can just see this. So we are considering a stack here, and after visiting it, we are just putting it into the visited nodes, and the another one which are not visited will be in this unvisited node list. So in this way we are going to complete this, and then 4 queens problem. So 4 queens problem is also one of the important problem. We need to just check it out. So now let us see this PPT. So while watching this PPT, if we just place the queen 1 position in the first position, then we can't either place the queen 2 or queen 3 or queen 4 in this row or column or even cross. So you can't place them in any of the either ways. So for that reason, you need to place this queen 2 in this position. Yeah, so after placing the queen 2 in this position, you can't place queen 3 like in this or even the cross. So that's why you place the queen 3 position here. So after so without placing the queen 3 directly, we just backtrack it to one step back, and we had changed the position of q1. So after changing the position of the q1, you can place the q2 here. So after placing the q2 here, you can place q3 here. So after placing q3, you can place the q4 here, so that no items will get collapsed. So in this way we can just do this, but for that we need to just draw some graphs. So we need to draw a space tree for this purpose. So after placing the q1, so we will place that as x1 is equal to 1, and then after placing q2, we will just place that as x2 is equal to 3, and after that we can't just place the x3 nowhere. So that's the reason now we are going to change that again. So after that we will just check x2 is 3. So x2 is 3 is already placed, so we can't just do that. So x2 is equal to 4. So if if q2 is placed in the 4th position, then we can just place this q3 here. So that's the reason we placed the q3 in the 3rd position. In this graph, some of the notations are not noted properly. So we need to draw a state space tree for this every single instance, so that we can just make some solution state space tree for this particular problem. So this is an iterative backtracking algorithm. We required backtracking very much in this problem, because if the place is not satisfied in that particular position, we need to backtrack and write for another node. So for that reason, backtracking is possible, most probably required. So 8 queens problem is a bit larger than that of this one. So for that this algorithm makes some sense. So this is n queen problem. So with the help of this n queen problem, we can work on this thing. So 8 queen problem is nothing but it is having an algorithm in that PPT. So you guys need to understand what is this 8 queens problem. So just reading this algorithm. In this graph color also, you need to write a state space tree. So for this graph color, the one and only thing which you need to follow is nothing but, so if we place a color here, it shouldn't touch this or this or this. So these three shouldn't touch that particular color. So for this also, if you draw a state space tree like this, you will get some clarity. So coloring is a very simple problem with which you can just work on, and you need to you shouldn't touch all the, so if you wear a color for one position, it shouldn't touch the remaining edges. So that's the one and only main constraint you need to make sure clear, and then draw a state diagram with the help of this 3 colors and this matrix. So in this way we are going to write this thing, and for the 8 queens you need to remember this n queens algorithm. So you need to just remember this particular algorithm, then only you are going to work on it. So the next one is sum of subsets. So sum of subsets is nothing but we will consider this example. So we will consider this example in a paint. After considering this example in a paint, so initially we will just add all the weights. So if we just add all the weights, so 11 plus 13 plus 24 plus 7, it gives me 65. So now I'm going to write my initial matrix as 0 comma 55. So after writing it as 0 comma 55, so now I will write a state space tree like this. So I will consider this as my first node, and then I will just draw a line like this, and I am involving x1. So after involving x1, we need to write something like 55 minus 11, that is 11 comma 44. So this is my first one. After adding this, we are going to add x2. So x2 is also added, that is 13. So 11 plus 13, that is 24 comma 31. So it is reaching the maximum weight. So with this you are going to complete the maximum weight. So for that reason you can't extend this particular graph anymore. So that's why we are going to remove the weight of the m. You can just continue now. So after adding 11 plus 13, so we will add 24 now. So after adding 24, it becomes 48, which is not at all possible. So that's the reason we will just add x3, but not possible. So now we are going to keep like this. So x3 is equal to 0. So we will not consider the value, but we will reduce the value of it. So x3 is 24, so 31 minus 24. We will keep the remaining value like this, x1, 31 minus 24. So we will be remaining with 7. So after having 7, so x3 is also added, and the last one is 7. So after adding 7, so we can just add 7 to it, 24 plus 7. So 24 plus 7 gives me 31. So I think this will make one solution. So now we are going to add x4 to it. So 24 plus 7 gives me 31 and 0 weight. Yeah, so this is forming a solution. So this is one of the solution in which you can just add x1, x2 when x4. So if you add this x1, x2, x4, then this will give our weight. So it will give the required weight now. So you can find out as many solutions as it is required. So in this it is showing even just like this. So now you can just write some graph like this, and then you can find out how many solutions it is required. So this is some of the subsets, and this is an algorithm which you guys need to remember for writing in an exam. So as this is an NSUM exam, CO3 most probably after solving the sum, as sums are a bit less, which are smaller sums, they may ask to write the algorithm. So that's the reason you need to make sure be perfect in the algorithms. Okay, now let us see CO4. So CO4's first question is a branch and bound method. So I think a branch and bound is so much familiar with everyone. So in branch and bound, basically they will give this 15 puzzle example. So I think this doesn't come in exams, but it is okay if you guys prepare. So this 15 puzzle example is nothing but you need to make 4 moves from this, like for up, for right, for down, for left. For everything there will be some up, down, right, left. So there is something, right? You guys need to make all those things, and you need to make arrangement of this all 15 puzzles to reach this goal state particularly. So basically they may just ask like explain 15 puzzle. So if they ask like explain 15 puzzle, and you guys can make a small moves like keeping an element like just here itself, or making up to 2 levels is quite difficult now in the scenario of exam, but don't make this much big complex example, so make it simple and clear. And then branch and bound method is nothing but, in branch and bound, breadth first search will be called as the Fifo. So with the help of this breadth first search, we are going to find out the least cost to reach the goal node quickly. So this is a theory where you can write theory as how many pages it is required, but drawing this particular thing is very difficult. It is not even possible for remembering also. This is too big. So if they ask something like explain branch and bound method with the help of 15%, then you can write something with the help of those breadth first search definitions and also writing regarding the least cost method and all those things, and you can just tell like this is my arrangement and I want to just find out this goal state, and you can write something which is having only 2 levels or 1 level. That's it. Don't make it too large to draw a 15 puzzle problem. So this is an algorithm for it. You need to remember this algorithm for the exam purpose, as this is an NSEM. So now let us see the next one, that is knapsack using Fifo, that is knapsack using branch and bound method. So knapsack using branch and bound method is also one of the easiest thing if you just remember. Let me just paste this in paint. So now basically we are just considering this image, so with the help of this solution we are going to plan it now. So now basically we need to just add this whole thing, like 10 plus 10 plus 12, that gives me 32. So 32 is my u value, whereas what is c? So c is nothing but it is nothing but a fractional value. So now here we can just see like 4 after 5 6 6 2 is 12, but 12 plus 9 is greater than m, as we can see here. 12 plus 9 is greater than the value of m, so that is not possible. So that's the reason we are now using c. So c is nothing but c is calculated along with the remaining part. So 6 plus 4 plus 2, 4 6 2 is 12, 12 minus 15 is it is remaining with 3 parts. So we can just consider like 3 by 9th of 18, that is c value. So we can consider like 3 by 9th of 18. I think there is no solution in this particular thing. So it actually gives me a value of 6. So now 10 plus 12 plus 6, that gives me 38. So in this way we are going to calculate those all values. So now initially we need to consider this as 1. So this is my c value, and minus 6 gives my u value. So we need to consider this, and we need to draw a graph like if we are considering u x1, otherwise x1 equals to 0. So we need to draw something like this. If x1 is being considered, then we need to do for that, and x1 is not considered, we need to do for that. And further we can just keep on increasing these nodes, and if x1 is there, after considering x1 we can do it for x2. If x2 is there, when we can just add. So most of the values we get this like minus 38 and minus 32 only whenever we are just decreasing towards this side. Like if you are not considering some of the values, then the values may get decreased. So that is when we need to perform calculations, like without considering x2. Like without considering x2, that is weight 2 p2. Here it is 6 after 7 8 2 is 16 plus 1, it is increasing the value. So 6 after 7 8, so 15 minus 8 is, that gives me 7. So 7 by 9th part of 18 we need to consider. So 7 by 9th part of 18 we need to consider, and we will get minus 22. So in this way we are going to calculate this whole branch and bound with the help of this Fifo. I think this made some sense. And now let us get into the next one, that is travel salesman problem. The travel salesman problem I previously discussed it in CO3, and this is a bit different. In this travel salesman problem, it is very easy to remember the method, but implementing that method in an exam is, it's a very big task. So here we can just see this cost matrix, and this is reduced cost matrix. So what is this cost matrix and what is this reduced? We will see it now. So here if we can see, first we need to perform row reduction and then column reduction, and then we need to just add those both. So the minimum, how to perform this? For reduction, min value of row and column is considered. So minimum value of row and column is considered. So for this the minimum value is 10, for this it is 2, for this it is 2, for this it is 3. Do not consider infinite, we need to consider only the numbers. And for this one it is okay. So now after we need to perform these values, so we need to, let us consider infinite as I. So 20 minus 10, 20, 0, 1. And for this 15 minus 2, that is 13, infinite. 16 minus 2, that gives me 14, 4 minus 2, that gives me 4, 2 minus 2, 0, 3 minus 2, that gives me 1, 5 minus 2, that gives me 3, infinite. 2 minus 2 gives me, and this is 2 minus 2 gives me 0, and this gives me 2. And like this 19 minus 3, that gives me 16, 3, 15, infinite, 0. For 16 minus 4, that gives me 12, 0, and then 3. 16 minus 4, that gives me again 12, and infinite. So in this way we are going to perform this row reduction, and again from this we need to perform the column reduction, that is I 13, 1, 16, 12. So 1 is the minimum value. So it is a bit complex. We need to perform the row reduction and column reduction, and we will get all those values, and we need to add upon all those row reduction and column reduction values, and this gives us L value, that is 25. So after considering the value of 25, then we need to draw the state space diagram for the smooth movement of our problem. So now basically we need to consider the value of 1, that is this first reduced cost is 25, and if we are considering 1 and 2, 1 and 3, 1 and 4, 1 and 5, as there are 5 rows and 5 columns, so if we are considering 1 and 2, first row and second column should become infinite. So yeah, now it is becoming like this, and also the 1, 2, 2, 1 values also should get infinite. So from now again we need to perform the row reduction and column reduction. If there are zeros, then we can leave it like that. If they are not having zeros as a minimum values, we need to perform the row reduction and the column reduction. And for that, after performing the row reduction and column reduction, we need to apply this formula, that is C of 1. C of 1 is nothing but, after performing this both, we will if they are having 0 as a value, then we can write the value as 0, and otherwise C of 1 is this 25, C of 1 is this 25, and then after performing 25 we need to calculate the value according to the state space 3, 1 comma 2. So if we consider 1 comma 2, we need to write the value of 1 comma 2 from here. From 1 comma 2 the value is 17, 1 comma 2, 17. So we need to write the value of 17 here, and we need to write the reduced cost also. Reduced cost is nothing but the minimum of the row, minimum of the column. We need to add those things, and we need to write it there. So that gives us another value. So we need to keep on writing for all this 4 values. So 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. We need to write 4 values for this, and we need to consider the minimum most for now, and then we need to continue. The minimum most from this 4 is 25. So from 4th node we are continuing. So from 4 to 1, 4 to 2, 4 to 3, 4 to 5. So here we are doing this problem. So after 4, so 4 also should get infinite, and 4 to 1, 4 to 2, 4 to 3, 4 to 4. So in this way we are going to consider all the nodes, and then we will perform all this C value operations. It is easy to perform the operations after watching this PPT or video, but writing in an exam is a complex task for this travel salesman problem using branch and bound. I think this makes some sense. And then next one, NP hard. So now let us see what is this NP hard. So NP hard, this is also purely conceptual based questions. So now let us just see what is group 1, group 2. So group 1 is nothing but it will contain all the problems whose solutions are bounded by this polynomial or a small degree range, whereas group 2 consists of non-polynomial that may exceed up to a greater degree. So there are two classes for non-polynomial time problems. They are NP complete and NP hard. So have the property that it can be solved in polynomial time, then it is NP complete. If it cannot be solved in a polynomial time, then it is called as a NP hard. So that this all things, it is okay if you read it by your own. And then Cook's theorem. So basically Cook's theorem is nothing but we need to prove that polynomial equal to non-polynomial. To prove this satisfiability, if polynomial if and only if polynomial is equal to non-polynomial. To prove this we need to just write all this whole theory. You need to remember this. I'm also not having a good clarity regarding this NP hard and NP complete, but this differences, if it is okay, if you guys remember these things, so that can be reducible into x in a polynomial time, machine in polynomial time. It do not have to be non-polynomial, it must be both non-polynomial and non-polynomial hard time. So it is possible. If you read this, there is not much remembering concepts in this, but in this PPT there are some concepts which we need to remember. That is click. So click is nothing but it is used to join in between two graphs or two trees. So it is something, a line, we can just call it as a line which joins two trees. So basically with the help of this click we are going to perform the CNF satisfiability click decision problem. So click decision problem is nothing but it need to touch all the fields in that particular graph. So you can consider only this example, there is no other example than this. So if you read click, then you can just read about this and you can just write it like with the help of this click it is going to make a combination in between these two vertices. So in this way we can just perform the click operation. And the next one is node cover problem. So node cover problem is nothing but we need to find a pair or a set of numbers with which it can touch all the vertices in this graph. So basically the answer is 2 and 4. With the help of this 2 and 4 we can touch all the vertices in this graph, and the size of that interval is just 2. We can also choose another intervals, they are 1, 3 and 5. So with the help of even 1, 3 and 5 we can touch all the nodes, but its size is 3. So node cover decision problem is nothing but we should be able to find a set of numbers with which we can touch all the nodes in the particular graph. So it covers all the nodes. You need to just read all these things. So I think this made some sense. So I had spoken about almost all of the important topics in this CO3 and CO4. Maybe this may not be as accurate as you know it perfectly, but the thing is it is very tough to explain the concept in deeper. So please try to read those PPTs and read those concepts and try to watch some YouTube videos, or you can just click on Google and read those things which are written. So you can just learn in either ways. You can just gain some information through those sources. So I had just made my small effort to just tell the important concepts for the examination purpose. I think this made some sense. So thank you for watching my video, guys. Please consider subscribing my channel and also share with your friends. Thank you.